Okay, so we're going to be working on chapter 4, and what we've done is we've kind of taken a lot of ideas out of chapter 4 and put them all into one kind of note sheet here, okay? So we're going to look at 4 different things today. We're going to graph using a t-table. We're going to determine if a graph is linear or nonlinear. We are going to interpret and sketch a graph, and then we're going to create a sketch given some information. However, before we get started and all that, I think we kind of have to go back to the basics here just a little bit and make sure that we understand how to graph coordinate points and what are all the parts. So what I'd ask you to do at this time is to go ahead and pause the video, and I want you to go ahead and try to identify the following parts on your grid, so just label them, and then go ahead and try to graph these, okay? So go ahead and pause now and see if you can do A and B on your own. Okay, so when we were identifying the following parts of the coordinate plane, x-axis, this was actually already labeled for you, but this would be right here, the x-axis is that horizontal line. And then we have up here, this guy right here would be the y-axis, or the vertical line. Okay, and then the next thing they asked you to find was the origin. Okay, so the origin is in the very middle here at 0, 0. Okay, so this right here is the origin. Okay, the coordinate point of this is 0, 0. And remember, when we're talking coordinate points, we're talking an x, then y, xy coordinate point. Okay, all right, the next part to it was the quadrants. All right, so when we're naming the quadrants, I am going to use Roman numerals, okay? So I'm going to have this is quadrant 1, quadrant 2, quadrant 3, and then quadrant 4. Okay? All right, so now with that being said, you're always going to start, quadrant 1 always starts where there's a lot of positives. So all of these would be like 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So all of your positives here, this is where we always start, and then we are going to go counterclockwise around. Okay? All right, so now graphing the coordinate points. The first coordinate point there we have is 2, 3. All right, so when you're graphing that, you're going to go over 2 on your x-axis, over 2, up 3. So right here, this would be your coordinate point, 2, 3. And then you are going to label it A. If you're doing a lot of coordinate points on one grid and they give you letters, go ahead and just label them for us. Okay, the next one should have been negative 3, 5. So negative 3, 5, 1, 2, 3. So you'll go over 3 and then up 1, 2, 3, 4, 5. So right here, we will put B. Okay. All right, the next one, 4, negative 9. So 4, negative 9, we're going to go to the right 4 on your x-axis, and then we're going to go down 9. So we're going to go 1, 2, 3, 4, and then down 1, 2, 3, 4, 5, 6, 7, 8, 9. And so our answer will be right here. So this guy right here will be C. And then the last guy here, D, 0, 3. So 0 means start at 0, don't go side to side, and then 3, go up 3. So this guy right here would be D. Okay? Now, just as a side note here, this guy, this D point right here, he is not in a quadrant. He's not in 1, he's not in 2, he's on the y-axis. So for some reason someone asks you what quadrant this is in, you would just tell them it's not in 1, it's on the y-axis. This guy would be in quadrant 1, B would be in quadrant 2, and then quadrant 4 would be your C. Okay, little vocabulary we need to kind of go over or review for some of you. Linear equation, linear. This means just line, linear, line. So it's an equation of a line, okay? Then we have what's called input and output. And we're going to talk about this more on the next page. But input is just numbers you're going to be plugging in, and then output will be numbers you're getting out. So input is your x values. You're going to be plugging in x's, and then you're going to get out y values. Okay, let's go ahead and flip to the next page. Okay, so now on this one, they're going to ask you to make a t-table. You're going to complete each table and then graph over here. Okay, so now kind of just reviewing what we just talked about. You have got input and an output. All right, this is your input. You are going to input the x. Okay, this is your output. This is what you're going to get out when you plug it in. So the first thing we're going to do is we're going to take this -2 and we're going to plug it in right here and get an answer. So we're going to have y equals -2 times -2 plus 5, which will give you 9. Okay, and you're just going to keep doing that. So the next one, y equals -2 times -1 plus 5, which will give you 7. Now plug in the 0, so -2 times 0 plus 5, you get a 5 out. Plug in the positive 1, and you end up with 3. And then plug in the positive 2 and get 1. Okay, so now when you do that, I want you to come over here, and you are going to graph these points. So -2, 9. So -2 and up 9 will be right about there. Oh, that's way too big. Let's try that again. Okay, so -2 up 9 will be right here. Then you've got -1, 7, 0, 5, 1, 3, and 2, 1. Okay, all right, so if I'm kind of looking at this, I'm going to connect these points here, and that's a terrible line, but you get the idea. All right, so you connect the points there. So then the question is this linear or nonlinear? Okay, so remember, linear just means line. So is this a line? The answer is yes, it's a line. So linear. Okay. All right, so I want you to go ahead and pause the video, and I want you to try to do the next one on your own. Okay, so now, looking at the next example here, you should have plugged in all your numbers into the x here. So you should have got -13, -8, -3, 2, and 7. Okay, so again, just make sure that you're taking this and you're going to just plug this guy in right here. So you'd have 5 times -2 minus 3. That's all we're doing there. Okay. All right, so then you should have graphed. Now, here's the kicker on this one. Your points have to fit on your grid. It's not an option. It has to be done. So you are sometimes going to have to change up your numbering. You're going to have to number your graphs. So since we had to go all the way down to -13 here, I decided to count by 2s. Now, I did go ahead and keep this just as -2, -1, 0, 1, and 2. Just to make it easier. So I counted by 1s on this, and I left the x's alone. But on the y's, I did count by 2 because we're going to have to get all points on the grid. So if you put that -13 down here in some random point down in here, okay, that's okay for now, but you're going to need to make that adjustment, okay? And then when I'm looking at it, is it a line? Yes, it is, so it's linear. All right, let's go to the next page. Okay, so now on this one, we're going to be doing the exact same thing, except for now we're going to be plugging in the absolute value. All right, so we're going to still take this -2 and we're going to plug it in right there. Okay, so now I've got y equals the absolute value of -2. Well, the absolute value of -2 is +2. All right, and then you're just going to keep doing that. The absolute value of -1 is 1. The absolute value of 0 is 0. The absolute value of 1 is 1. And the absolute value of 2 is 2. Okay. All right, so now we come over here. Let's do our grid. So -2, 2. Up 2 right there. -1, 1. 0, 0. 1, 1. And 2, 2. So when you have an absolute value, it actually is going to look like a V. Absolute values, when graphed, will look V-shaped. Okay, so then we ask ourselves, is this a linear or nonlinear? Well, yes, I agree there are 2 lines here, but this is nonlinear. It has to be one continuous line. You can't be shooting off in 2 different directions. So in this case here, it's going to be nonlinear because it's not a line. Okay, all right, let's go to the next one. So now you're going to do the exact same thing, just plug it in. So you're going to take the x's and plug in. So I get -2 squared. So that's 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. Okay. All right, so let's come over here and graph. -2, 4, -1, 1, 0, 0, 1, 1, and then 2, 4. Okay. All right, so when I'm looking at this guy, this is not a V. There actually is a little curve to this, and it's called a parabola. Parabola kind of looks like a U. U. So if I come over here, anytime we have an exponent of 2, you're going to have a parabola, some sort of U-shaped. It doesn't matter if it opens up, down, side to side. That doesn't matter. It just needs to be U-shaped somehow. Okay? All right, so then our next question is this a linear? Well, if it's a U, it's definitely not a line. So this would be nonlinear. All right, go to the next page, please. Okay, so now we're going to be looking at the following t-tables. So we're looking at the following charts, and we've got to figure out if it's linear or nonlinear and explain. Now, you could fall back to graphing, and you could always put, do your x, y, and do some points and figure out what's going on, okay? Or you can kind of start looking for patterns. So when I look at number 1 here, okay, first thing I'm going to look at is, does this X follow a pattern? So in this case, we're just going up by 1, 1, 1, and usually it will, but sometimes you got to be careful because sometimes they will jump around on you a little bit, and that doesn't mean it's not a line or linear. It just means you've got to kind of pay extra close attention on those, okay? But this won't right here always be the case. So just be careful if they start jumping around and leaving out numbers. But here we're going up 1, 1, 1. So once you are sure that you've got something good here, let's go to this right-hand side, look at the Y column, and let's figure out, is there a pattern? Now, if we're looking for something that is linear, okay, so linear, nonlinear, we're looking for linear, we will be doing addition or subtraction on the Y values. Okay, so if it's not addition and subtraction, then you need to, it will be nonlinear, okay? All right, so if I come here and I look at this guy, so if I'm looking from here to here, what do? We add 2, and add 2. There has to be a pattern. It has to be the same thing all the way through for it to work. But in this case, because you're adding 2 continuously, that is a line. You're adding the same number every time. So in this case, it'll be linear. And then I believe they asked you to explain. So on your explanation here, I would probably just write down something about you're adding 2 to the Y values. Okay, so don't you take a second there. So explain. Adding 2 to the Y values. Okay, and this works because we know if we're doing addition or subtraction by the same number all the way through the table, that's going to make it a line. Okay, let's look at the next one. So first off, again, we're checking the Y's or X's to make sure there's some sort of pattern, okay? And in this case it is. It's just going up by 1s. So now we come over here and we're trying to find some sort of pattern. What's going on here? Well, if you're looking at this, you go up by 2 here, and then all of a sudden you're dropping down by 6, and then all of a sudden we jump way back up by 11. So if I'm looking at that, this is just a hot mess. I mean, there's no pattern here. It's not the same thing all the way through. While it is all addition and subtraction, that's great. It has to be the same number. All right, so in this case, this would be nonlinear. Okay, and then we could say Y values do not follow pattern. Okay, all right. Let's move on to the next example. Okay, what I want you to do now is I want you to go ahead and pause this video. I want you to go ahead and set up your table. So you're going to graph these over to here, so you are going to have to number, and then also make sure that we give it a title and that you label your X and Y axis. So go ahead and pause and do that. Okay, so here you're looking at, I just basically just took this and transferred it over. Got minutes, make sure you labeled. All right, calories right here, and then I just went up by the 50s. And then make sure to give it a title. I just wanted to review with you the graphing just to make sure you remember labeling everything, okay? And then also just make sure here on these X's and Y values that you are going up by the same amount. So here I'm going up by 10. I'm going up by 10, 10, 10. Here I'm doing 50, okay? Remember, we're not doing big jumps like we count by 100 and then count by 10s, okay? All right, let's go ahead and flip over to the next page. Okay, so for example 5 here, Graphs of a relation, okay? So the value of a variable in a relation is the subject of choice called independent, okay? So basically we have two ideas here. We have what's called independent and dependent. Independent is going to be your X label. So in this case, independent on both of these would be time. Now, with that being said, in fact, I'm going to put that in there right now. Time is always going to be independent, okay? So time will always be independent, okay? All right, and so we have independent and dependent. Now, dependent would be your Y values, okay? So in this case, the height of the football is dependent on how long it's in the air. So if it starts at the ground and then goes up and comes down. Or this guy, we're talking about stocks over a period of time. The stock prices change, but if time doesn't go anywhere, then the stock prices can't change. So X will be your independent, which is your time in this case, and then the height and the price are going to be your dependent. So dependent is something that depends on the time. Price depends on the time. Height depends on the time. All right, so independent is also associated with your X values, which is called domain or input, which we just talked about. Okay, now domain and range, these are going to be words you may not know yet, and that's okay. We're going to hit those a little harder later in this chapter. Dependent is your Y values, range, or it's also considered your output. All right, so for this, it says one of the following examples is a good description of a graph, and the other is a poor description. Determine which is which and explain your reasoning. So I want you to take a second here. I want you to pause the video, and I want you to read through these two, and I want you to circle the one that you think is the better description. All right, so right here, this would be your description in this. So circle the one that you think is better. Okay, so when you're looking at this, you should have picked this guy right here. Now, in both of your descriptions, independent is time, independent is time. They got that part right. Dependent is height, dependent is price. So both of those are good. So then we start reading. The football starts on the ground. When it is kicked, it gains altitude until it reaches the maximum height and then loses the altitude until it falls to the ground. So in this case, they're talking about exactly what happens. They're talking about the start point, how it's on the ground, it goes up, it comes back down, and then they talk about how it falls back down to the ground again, okay? Where on this guy, it just says the price increases steadily, then falls, then increases, and falls again. And that's fine. That gives you a kind of a little bit of a general idea, but some things they probably should have talked about here was that your price should be starting positive or up above zero, okay? That you do increase, but you decrease for a short amount of time compared to the increase. So I have a longer increase, a short decrease, a really long increase, and then a very short decrease, okay? But we're still finishing higher than where we started, and I think that's important. So when we're looking at something like this guy right here, I would expect you to talk about the start point. That would be number one. I would expect you to talk about the increase, number two. Talk about how you start decreasing. Talk about your increase again, your decrease, and then talk about your finishing point. Okay, so that would kind of be the 6 things in this case that I would expect to see out of you to talk about. So on these, when you've got something that has more lines in it like this, you have to talk about each section. When you have something like this, these are a little less descriptive because you just talk about how it starts in the ground, goes up, comes down, finishes on the ground. Okay? All right. So example 6 here, it says identify the independent and dependent variables for each relation, then describe what is happening in each graph. All right, so the graph represents the speed of the car as it travels to the grocery store. All right, so here's the speed of your car. So identify independent and dependent. So independent. I'm just going to go ahead and put an I next to this. Your time is independent, right? Anything on your x-axis is independent. And then this guy would be your dependent, so your speed, okay? All right, I want you to pause the video and I want you to take a second and write your own description of this graph. Okay, so in your description, we're going to start with, did you start with talking about how it starts at 0 speed? So at the start, the speed is 0. That's how you should have started it. At the start, the speed is 0. The car then accelerates or increases in speed, however you want to say that, for a period of time. So this would be one thing you should talk about. This would be the second. Okay. Now, this guy right here, he's going at a constant speed. He's not stopped. He's going at a constant speed. All right. So then you talk about how they got the constant speed. So it'd be like grocery store. I'm leaving my house. I accelerated. Maybe I pulled onto the interstate or something. I've accelerated. I'm going at the same speed. And then let's talk about this part right here. You're coming to a stop. All right. And you need to talk about that. Where's your ending point here? So you need to talk about how you're going to come to a stop. But you also need to talk about the deceleration. All right. So you need to talk about how we stop quickly. Look how quick this is, how steep it is compared to this guy. So my acceleration was a little slower. I went for a little while at a constant speed. And then here I decelerated quickly until I came to park or stop again. All right. So now if you read your description, you should have 1, 2, 3, 4, 5 things talked about in there. Okay. All right. Let's go to the next one here. I want you to go ahead and pause your video, talk about independent, dependent, and then give a description. Okay, so your independent should have been the depth, okay? And all we can do is read information that we have here, and that's the best we've got. So we're talking about the temperature of water, okay? We don't know if we're lake or ocean or what. We just know what's the temperature of water. We know the depth. The higher that depth goes will be independent. And then here we know the dependent, or sorry, the temperature will be your dependent, okay? So now in your description, you need to talk about time is positive, or sorry, temperature. Temperature is positive. We don't know exactly where. We just know we have a positive temperature. And then you just talk about how it decreases as the depth gets larger. Okay, so think about it. If it's 0 and then I have like 100, 200, okay? So as I get deeper into the water, my temperature starts to drop, okay? So again, you want to talk about your starting point, how you started above 0. You want to talk about getting colder the deeper you go. And then you want to talk about your finish here. Oops. Okay, so again, you would just talk about the temperature of the water, starts above 0 and decreases the deeper I get. All right, let's go ahead and flip to the next page. All right, so now what we're going to do is we're going to go backwards. So they're going to give you a brief description, and your job is to come up with the picture, okay? Then you'll also need to identify independent and dependent variables, and let's make sure we do our labels, okay? So this is the height of the baseball after it is hit. Now, I always love this one because we always have a lot of people who want to start their baseball on the ground. However, if you think about hitting a ball, you are not going to start at 0. You're going to start somewhere up higher, right? We're not playing golf. This is baseball. All right, so when you hit the ball, it might come up and then it might come down. Now, in this case, I am fine if you hit the ground. I am fine if you stopped it and maybe did something like this where you went up and then came down and then stopped it here because maybe it got caught. We don't have that information. All right, so all you can do, oops, sorry there. All you can do is read the description, all right, so what we have up here, and then sketch it to the best of your ability, okay? So some of you might have it hitting the ground, and some of you might have maybe it got caught in the air. Now, it'd also be fine maybe if it was more of a line drive, but there'll still be some sort of arc. It'll still come up and then kind of come back down. All right, so the height of the baseball after it is hit. Okay, so this is going to be time. How long is the ball in the air? And I'll give you a hint, guys. Time is always pretty much going to be on your x-axis, okay? Time, x-axis, is your independent variable. And then we need to look at what else are we looking at here. And in this case, it's going to be height. So we're going to put in height for our y. All right, and then maybe we'll give it a title. So I'm just going to put baseball. Okay, so that would be an example of a sketch. Now, not everybody's sketch is going to be the same, and there's going to be a lot of correct answers here. Okay, and then also make sure you identify independent and dependent. All right, I want you to take a second. I want you to try B on your own. So pause the video and let's see what you come up with. Okay, so we're talking about temperature, and then the other part here is time. So we have temperature, and then it's talking about how it warms up during the day and at night. So we're talking time. So we're going to have time down here, temperature on my Y, and then I'm just going to put daily temps. Okay, it doesn't matter, just as long as it's something that goes along with the problem. Okay, all right, so the temperature warms up during the day and then decreases at night. So if you're thinking about warms up during the day, so this would be like midnight, 12 o'clock, and then you're going to go hit noon during the day, and then you'll hit like midnight again, okay? So you don't need to put the numbers in there. I'm just trying to give you an idea here. So now, we don't know exactly where it started. It didn't say. So I don't care where you started it at, okay? Just start it on the y-axis, and then it says it goes up and then comes back down. Now, I'm not going to put mine all the way at 0 because I don't want it to 0 degrees outside, so I'm going to leave mine a little higher. Now, I usually have kiddos who will say, well, we did something like this. It went up and then kind of flattened out and then went back down. That would be fine. That would be the same thing. And it would be even okay if you brought that all the way down to 0, because we have no information here that tells us what else is going on. All we know it's going to go up, and all we know is it's going to come down. All right, and that concludes the notes for chapter 4.